Hello, this is Mr. Stansbury. I'm going to take you through the notes on intersection of graphs. At the end of this, you should be able to say, I can find the coordinates of the intersection of two graphs. Okay, so this is important. Good stuff here. When a quadratic function and a linear function are graphed on the same set of axes, there could be two, one, or no points of intersection. So it could be cutting. There's our 2 points of intersection. It could just go through and just touch, call it touching, and that is just 1 point, or it could be missing where there's no common points, okay, no intersections. So let's get straight into how to do this. Example 19, find the coordinates of the points of the intersection of the two graphs with these equations, okay? Now we can actually solve this with good old math, but you know what? We can actually also do this on the graphing calculator. So that is really probably the fastest, easiest, most efficient way and has the least chance of coming up with an error. So let's try this out. I'm going to show you these. Okay, so we're going to simply enter this in just like it looks. Here's our x. That's always our variable button, xt, theta, and n. So x squared plus 3x minus 5 is the first one, and then we'll go to the second one. That's 2x plus 1. 2x plus 1, okay? Normally you only have to do this usually the first time. I would do zoom standard, number 6 there. It'll give us a nice little, it'll zoom it into by 10 by 10, I believe. So there's our x squared plus 3x minus 5, and then here's going to be the 2x plus 1. So we can tell right there it intersects at 2 spots. Now here's the nice part. We can actually go through and figure out what those 2 parts are here. And this is where we're just beginning to learn how to use our graphing calculator. A really important, useful button on here is going to be the calculate, which is second trace. So we do second trace, which is going to be calculate. And we're going to calculate, in this case right here, we're going to find the intersection. So we're going to do 5. We're going to calculate the intersection. Okay, now it's going to ask you some questions. First curve, is this where you want the first curve to be? Sure, because you could have like several different graphs on here and they want to know which graphs you have. We only have 2, so it makes it really easy. But now here's the key. If I want to find this one first, I want to get this cursor over here close, but not right at that intersection point. I just want to get it closer to this point here. Like that's closer to this point than that point for sure. So I'll say first curve, yes, I'll push enter, and then you'll notice it's going to jump up to the other line and say second curve, yes, that's the second curve that I want to find the intersection of, and then it's going to ask you again and say, hey, do you want us to guess? Sure, it actually goes through and calculates it for you. It's not going to guess. But there it is. It gives you that, and I can't read that. That's awesome. Let's see, why is that not readable? Sure, why we couldn't read it, but now we can. It's x equals -3 and y equals -5 is one of the 2 intersection points. So -3, -5 is one intersection, and then the other intersection, we just do the same thing again. Second trace, which is calculate. We're going to find the intersection, which is 5, or you can scroll down and push enter. And then first curve. Now, if we chose that as our first curve and the second curve, it's just going to find the same intersection point. So now what we got to do is we got to scroll this thing over until it gets closer to the other intersection point. Okay, so now it's definitely closer to that intersection point. And you want it to be closer to that intersection point on relative to the x-axis. Okay, so first curve, yes. Now I push enter, it's going to go up to the second curve, yes. And then do you want us to guess? Sure, guess away. Okay, and they guess, and we get 2 and 5 is the other intersection point. And that is our answer. Find the coordinates of the points of intersection of the 2 graphs with the equations. Those are our 2 intersection points. Now, doing this by graphing calculator, you need to make sure that you enter this stuff incorrectly. Because if you put one little thing in wrong, you're going to end up with the wrong intersection, and it's really hard to give you partial credit with not being able to see what you had entered in your calculator. So make sure you're super efficient and careful on this. Make sure that you are putting in the correct data. Okay, we're going to look at another one, but first, let's look at a little comedy clip.
15, 30, 40 game. How come somebody didn't go to that first meeting, that first scoring system meeting? I know I'm late. And I hope I'm not out of line. I see all that trigonometry you have on the board. And I can only imagine you've already discussed this, but instead of that, why not 0, 1, 2, 3, 4? Okay, Charlie. You hear Charlie's idea? Charlie thinks little numbers is better than love, 15, 30, 40, deuce, my ad, 30, 50, your ad. He thinks little numbers is better than all that.
All right. Let's look at our second and last example. Same thing, but now it's actually giving us two quadratics. Okay, so same process. We're just going to enter this in. We're going to go into the y equals, clear out our original 2 that we had entered in. Oops, that did not work. Clear. There we go. Now we're going to enter these in. X squared plus 3x minus 3. So x squared plus 3x minus 3. Enter, and it'll take us to the second one. And then we got negative x squared. So when you're doing negative x squared, do this, not subtraction. Do negative x squared minus 5x plus 7. Okay, and we've already did our zoom from before, so we don't have to mess with that anymore. But if you end up your window looks goofy, then you can just always go back to zoom standard, and that will get you a couple nice, it'll get you this 10, positive 10, negative 10 on the x, positive 10, negative 10 on the y. Okay, and then here's our graph, and it looks like it's intersecting again at 2 spots. So to go back and find those, we will do second trace, which is calculate, and we want to find the intersection. So that's the 5. Okay, now I usually just, by habit, I just like to start with the one on the left first. So I'm going to just scroll over there until I get a little bit closer to that one. Okay, that looks like that's closer to this intersection. So it's going to say first curve. Yep, I want that one. And then it's going to jump up to the other one. If you're over here farther, you might actually not see it jump to the other curve, but it's still there. And you can even see let's see. Actually, I guess you couldn't see it, but normally you can see the x coordinate in there. Anyway, that is the second curve, so we will push enter and then guess. Yes, I want you to guess / calculate. Here is the first intersection point, -5 and 7. And then we will go back in, and then we're going to get it closer to that section over there after we do second trace, which is calculate, number 5 intersection. And now we got to get it closer to this other one here. I think if I hold it, it'll get going. There we go. So again, as long as it's closer x-wise, that's closer x-wise than that one. So this should work. First curve, yes, enter. Second curve, enter up there. And then guess, yes, push enter, and it should show it right up there. And there it is at 1, 1. Okay. And that is how you find the intersection of two graphs using your graphing calculator. Okay. Now, sometimes they will not give you nice, pretty answers like this. Sometimes it'll be weird decimal answers. Just pretty much as a good rule of thumb, just always round it off to the nearest hundredth, and you'll be good. Unless it says something different. Okay. All right. That's all we have for intersection of graphs. If you have any further questions, please feel free to ask. Thanks.